The future of AI computing just arrived. Google and Nvidia have unveiled the A5X Cloud Supercomputer at Next 26, and it could change everything. Welcome to The Explainer. Today we are diving deep into the massive new infrastructure that's being built for the next era of artificial intelligence. You see, it's all about a huge shift from an AI that just answers our questions to an AI that actually takes action. And believe me, that requires a completely new level of power.
So for the last few years, our whole interaction with AI has basically been a dialogue, right? We ask a question, it gives us an answer. And yeah, it's been pretty revolutionary. But now the entire industry is asking a much bigger question. What happens when the AI stops just talking and starts doing?
The next step here isn't just a smarter chatbot. It's about a collaborative system. Imagine telling an AI, hey, plan my entire product launch. A primary agent would hear that and then immediately break it down into dozens of smaller tasks. Market research, drafting social media posts, analyzing the budget, and then it assigns each of those tasks to a whole team of specialized AIs that all work together to get it done.
This is what Google is calling the agentic era, and it really is a fundamental shift. Just one single instruction from you could kick off this complex, cascading series of actions. And that creates this incredible, almost unbelievable power. But it also presents a massive, massive challenge for the technology that's running in the background.
You can't explore a new world with an old map. And you definitely can't build this new era of AI on yesterday's hardware. To really navigate this new frontier, you need a system that's purpose-built for the job. Google's answer? Something they call the AI hypercomputer.
And this, right here, is the key idea. The old way of doing things was, you'd buy powerful chips from one company, your networking gear from another, storage from a third, and then you'd spend all this time trying to stitch it all together. The AI hypercomputer is different. It's designed as a single, massive system, where the hardware, the software, the networking, it's all built from the ground up to work in perfect harmony.
Okay, so let's pop the hood and take a look at the critical components that make this whole machine run. We're going to start with the engines that do all the heavy lifting. The computational hardware itself. So, for the very first time, Google is releasing two totally distinct versions of its 8th generation Tensor Processing Unit, or TPU. On the left, you've got the TPU V8T. The T is for training. Think of this as the powerhouse, the heavy lifter, designed to train these enormous AI models in just weeks instead of months. And on the right, you've got the TPU V8I. The I is for inference. This one is all about pure, real-time speed, making sure those AI agents can respond instantly so conversations feel natural and not laggy.
But hey, it's not just about TPUs. The AI hypercomputer is built for choice and flexibility. It's going to be one of the very first systems to feature Nvidia's next-gen Vera Rubin GPUs. It also uses Google's own Axion CPUs, which are absolutely crucial for handling all the thinking that happens around the main AI model, all that logic and tool use that makes an agent truly smart.
So you've got all these different engines, thousands of them. But all that raw power is completely wasted if they can't all communicate with each other at lightning speed. So now let's look at the nervous system that ties all of this incredible compute power together.
The solution here is a brand new networking protocol called Falcon. And as you can see from this timeline, this thing was not developed overnight. Nope, this is the result of almost a decade of deep, focused research into solving the unique challenges of networking at a massive hyperscale level.
And this isn't some secret sauce they're keeping to themselves. Google is actually contributing Falcon to the Open Compute project. They're working with partners like Nvidia and Intel to make it an open standard that can help advance this kind of infrastructure for the entire industry.
And this open approach is really getting noticed. Key industry players like Arista are pointing out the big breakthrough here. It's a protocol that's powerful enough for these extreme AI workloads. But, and this is the key part, it works over the standard Ethernet networks that already power the internet. That is a huge deal for adoption and scale.
Okay, now what's really interesting about this slide is what it shows about Falcon's resilience. This graph here shows what happens when you start losing data packets, which is a really common problem in massive networks. Notice that blue line, the good put. Even as packet loss climbs to a really high 5%, the performance degrades gracefully instead of just falling off a cliff. And that stability is absolutely crucial for reliable training.
So, we've got the engines and the nervous system. What about the fuel? Well, to make sure these powerful systems are never, ever starved for data, the storage system can deliver a staggering 10 terabytes per second. To put that in perspective, that is fast enough to download thousands of HD movies every single second.
It's a 10x improvement over just last year. Incredible.
Okay, so the hardware is all in place. But how do you actually manage the chaos of thousands of AI agents all firing up at once? You need a conductor to orchestrate the whole symphony. For the AI hypercomputer, that conductor is the software layer, Google Kubernetes Engine, or GKE.
To make these agents feel truly instant, every single millisecond counts. So GKE has been completely supercharged. The underlying machines now start up to 4 times faster.
The containers, where all the code actually runs, their startup times have been slashed by 80%.
And one of the biggest bottlenecks traditionally, loading the AI models themselves, is now 5 times faster. It all adds up to getting these AI agents ready for work in just a fraction of the time it used to take.
So the most crucial point here is this. GKE is now using AI to manage AI. Its new inference gateway doesn't just guess where to send a request. It actually uses machine learning to predict network traffic and route requests intelligently, all in real time. This cuts that critical time to first token, that little delay before an AI starts responding, by over 70%. And that's the difference between a conversation that feels natural and one that just feels laggy.
So, by co-designing every single layer of this stack, from the custom silicon all the way up to the orchestration software, Google has created this incredibly powerful and unified foundation. It's one that's designed specifically for building this next generation of agent-based AI.
And what's really critical is that this isn't a lockdown system. It's not a walled garden, it's built to be open, with full support for the tools developers already know and love, like JAX, PyTorch, and VLLM. The goal is to let builders use the absolute best foundation, without forcing them to change the way they work. And this really illustrates the end goal perfectly. This isn't just infrastructure for Google's own products like Gemini. No, it's the foundation that any company can use to build their own custom, sophisticated AI agents. It's about translating all these technical innovations directly into real business value.
So, there you have it. We've seen the frontier of this new agentic era, and we've seen the powerful engine that's been built to explore it. This is the foundation for the next decade of AI. And that leaves us with just one final, really exciting question for all of us. What will we build with it?
With unmatched speed, massive scale, and next-gen AI power, the A5X may become the engine behind tomorrow's intelligence.